Hello, everyone. Frenetics' first mini seminar is happening today. Let's move this. Yeah, Belinda will challenge me later, so I'm expecting that. Okay, yeah, yeah. Oh yeah. All right, we'll be starting in 2 minutes. All right, I'm gonna start right now. All right, so today in the mini series, we're gonna be covering COVID-19 testing and the different types available. This meeting was scheduled for last week, but due to the lockdown outbreak, I'm so glad that we're able to start our first session of the day and of the year. Can you hear me? All right. Can I just take? Yeah. Let's see. So a brief outline of the presentation. We're going to start with some background of what COVID-19 is and where it all started, and cover through the three main tests: RT-PCR, LAMP, and antigen and antibody. And then afterwards, we have a 10 to 15-minute session of Q&A and happy hour. So it has been 1 year looking back, ever since the COVID-19 pandemic has happened, right? And crazy to believe, right now it's February. And last year, well, roughly January 2020, China on the 31st of December notified the world about the coronavirus outbreak. Then on the 30th of January, COVID-19 declared a public emergency by the World Health Organization. And then on March 2020, WHO declares COVID-19 a global pandemic, right? And it's crazy to think that time kind of flies throughout this whole time. And after 1 year, this is where we are now. If you look at current statistics and you compare the United States to Hong Kong, the United States cases versus Hong Kong cases, they're quite staggering, right, in numbers. Even if you look at mortality figures and death rates, it is also quite a remarkable difference. And it just shows how Hong Kong and us as Frenetics are really dealing with the situation. If you're looking at Hong Kong's daily change for the number of cases, you can see that so far we have outbreak number 1, 2, 3, and then we know that outbreak, the third wave or the fourth wave never really ended. But our recent efforts in the past 2 like lockdown cases, you can see that now the cases are finally going down. So hopefully this means that bars and normal activity will resume as long as we practice good hygiene and focus on battling the pandemic. So Prenetics has been on the forefront of the world for COVID-19. From the English Premier League, we have been focused on and supporting the operations there for the soccer testing. In addition to the Hong Kong Singapore travel bubble prior to the third wave, our team here at Prenetics have been focused on getting that launched. And unfortunately, that has been postponed. But in addition, we have collaborated with Tatler and Black Sheep in Hong Kong, working with these restaurants to provide on-site testing as well as UK airport testing as well. We have set up 4 laboratories there, 1 in Heathrow, 1 in Manchester, and 2 more as well. So you can see that our impact as a company is pretty global and widespread. So to go over some background and understand some public health terminology of how COVID-19 is spread, it is important to understand the chain of infection so that we really can get a bigger overall picture of how this whole thing works. Yeah. So first of all, we have the infectious agent, which we know as SARS-CoV-2, right? And the thing is with this virus, it cannot live on its own outside, right? If the virus is outside, in the air, on a surface, it actually cannot survive out there, probably only up to 3 to 5 hours, because it actually needs a reservoir, a host per se, like someone, Mac would be a great person that a virus would love to infect because he's a healthy, strong human being, right? Other people or animals would love to get infected as well. So viruses can only stay in live organisms. Yes.
So what about all those UV light solutions and stuff like that? How is that should be something? Like you have like these UV sanitizers that people use for knives and kitchen utensils in some places. You know the UV
Yeah,
lights.
the UV lights. Yeah.
How legitimate is that?
they are as limited as they can get because they're on a nano level. They are already eliminating the virus because they are very small. In fact, because you can't see them. They're in another mini series. We'll talk about how small the virus is, but the UV is one of the strongest ways to actually kill the virus. Yeah. Um, moving on. So an animal or human being, the portal of exit is the mouth, where or the nose, where like droplets, right? That's why we wear masks because from coughing, exhaling, sneezing, singing, or even speaking, whoever's infected can easily transmit the virus. That's why if you look at the Hong Kong dance groups, right, that whole cluster was easily transmissible because when people are not wearing masks and they're dancing and talking a lot, that can SARS-CoV-2 likes to transmit through those pathways, right? So the modes of transmission is that, if somebody sneezes or coughs and that aerosol is in the air, then if you're not wearing a mask, you can get that. Or if you haven't washed your hands and someone's sick, has been touching different surfaces, and you eat your food without washing your hands, then that's how you get sick, right, through the portal of entry. So if you have contracted COVID-19, then those who are elderly tend to be more susceptible to getting sick and developing more symptoms, while those who are younger and healthier, according to current studies, have shown that they're less likely to be affected. Yeah, any questions? Yeah.
So you were saying that like humans, that those viruses in their hopes to survive or
Yeah.
die in 5 hours. So if the animal, like a pet, is infected, and the pet is also reinfect the humans.
Yes. Even if it's pet, like that's how it all, the whole bat theory, in the Wuhan. Like
cats and dogs. And,
yes, yes. Studies have shown from the New England Journal of Medicine that cats, especially tigers, that whole species can infect and contract COVID-19, and they themselves, if they, they're, I guess they're licking the floor or something, and that is, transmissible. Exactly. Yeah. Exactly. It's only through the mouth, right? Because that's where the droplets are transmitted, but not like through like the skin, right? Okay. So back to COVID-19 testing. So if you think you have contracted COVID-19, so what are the current available tests are in the market? Does anyone know? Yes.
RT-PCR.
Nice. Yeah, that's one. Yeah.
Antigen.
Yeah.
Antibody. That's the same, right?
No, it's different. No. Yeah. That's pretty much it. We have RT lamp. It hit the spot over there with oxide technology, and we have PCR test and the antigen and antibody test. So today we'll mainly cover these 4 tests and specifically understand how does the RT-PCR test work, as well as how does a Prenetics oxide lamp differ from the RT-PCR test. So RT-PCR, stands for reverse transcription polymerase chain reaction. Right? That terminology in and of itself sounds very difficult and tough to understand, but don't worry, we will break this down and make this easy for you. So first of all, let's just consider the question, why is RT-PCR the gold standard? First of all, it's the gold standard because for years, RT-PCR and other diagnostic assays has been used as a common laboratory test for different assays and diseases. And especially for COVID-19, it has a 98% sensitivity and 100% specificity for the test, right? So it's a benchmark, which is why it's gold standard. Best thing about it is that it's dynamic and flexible in terms of sample type that can be processed, either swabs or deep throat saliva. Mainly in Hong Kong, deep throat saliva is processed here, while swabs is the most common method predominantly in the world. And on average, with the RT-PCR test, it takes about 2 to 5 days for the results to be processed. But at Prenetics, with our express service, we can provide these results as fast as up to 6 hours. Right? So it shows that the whole operation and our dedication to providing this result and making this whole flow as optimized as possible.
What's specificity?
Specificity. Specificity is defined as how specific. I don't want to use the same word, but how well can it match the test that it's actually looking for, right? So if you're looking for Let me find you an analogy.
Because you're looking for the DNA of the virus.
Yes, no, specific is there's so many different viruses out there, right? Like the old SARS. So specific is if you're doing this specific, if you're doing this test of SARS-CoV-2, will it detect other strains of viruses or will it just detect SARS-CoV-2? That's specificity for
You're
you.
looking for the DNA of the virus.
The RNA, yeah.
Yeah.
The RNA is converted into the DNA. Yeah.
So I guess some tests, let's say hypothetically, there's another test for another disease out there that's 92. That means there's an 8% chance it might detect another disease accidentally. But
Yes,
in this case, if it detects something, it's 100% going to be the right thing.
yes, yeah. False, false positive or false, yeah. What's the possibility?
No, I mean, the definition.
No, that comes with sensitivity. Yeah,
Then.
yes. Uh, false positive, sensitivity. False negative, specificity. Yeah. Yep. Any more questions? Okay. Moving on. Okay. To understand reverse transcription, let's not focus on the molecular details, but the key thing to understand what reverse transcription is the process of converting RNA to DNA. Okay. So RNA is a single strand molecule and DNA is a double strand molecule. And just remember that RNA is SARS-CoV-2 because SARS as a virus only has RNA and it's the genetic blueprint or the brain or the heartbeat of the virus. While in humans, we have the DNA, right? It's the genetic blueprint of what we have, you know? So like if you do the circle DNA test, it's what you're looking for, your innate molecular properties or textbook definition of who you are. Okay? So once reverse transcription converts RNA into DNA. And once that happens, PCR, the polymerase chain reaction, can happen. The important point here is that PCR can only amplify DNA. That's why reverse transcription is a key step from converting virus, the SARS-CoV RNA, into a SARS-CoV DNA, so that our PCR test can amplify DNA multiple times, no matter the viral load, the amount of copy number present, so that it can amplify the virus. So how is the virus amplified? There are a set of PCR primers, and I'm pretty sure you heard the word primers many times. The best way to think of a primer is that it's like an instruction guide for how to do something. And in this case, it's how to create more copies of the DNA.
Would you repeat that, please? I feel like.
Yep.
Got lost.
Got lost in the process?
Yeah.
Okay, sure. Step one for how a PCR works, it's called RT-PCR, right? Reverse transcriptase, reverse transcription. So the first process is to convert the virus RNA into DNA. And why is that done? It's so that the PCR can amplify DNA, right? Because it cannot amplify the virus RNA. So that's why this conversion needs to be done so that the PCR can actually detect the virus and just constantly repeat itself over and over again. Yeah. So the next slide shows you on a molecular level how this works. Yeah, you just see these RNA and DNA strands constantly being extended, and this is what we call amplification on a molecular level, right? But I'm not sure if you had a chance to take a look at articles that I've sent out, but in short, an analogy for this is to imagine a big library, okay? You're in a big library, you want to find a book, and you have an RNA molecule that's single strand that doesn't have the complete information. So you know that the book title is Harry blank and the blank of fire, right? So some of you know who know the Harry Potter series might guess what the book is, but you have a primer. So you send the primer out in the library to go find the words Harry and the fire. And when it goes to the library and search out the possibilities of Harry and fire, in the end, it would find out the word Harry Potter and the Goblet of Fire. So that's what the primer does. It's like an instruction guide for say, hey, how can I find these words in the library, pick them out, and then amplify it. So that's why over here, once the primer has found what these words are, it would amplify Harry Potter and the Goblet of Fire 1 time, 2 times, 3 times, and so on until you can detect the virus through fluorescence. Yep.
So for instance, primer makes the RNA.
Primer makes the RNA DNA. No. No.
Reverse transcription makes the RNA DNA. Right?
Yes. Yes.
And then you apply the primer on top of the DNA.
Yes. The primer is pretty much on top of the DNA. It's the first thing that comes before it. You can just imagine the primer before these molecules is the first thing that it reads and say, okay, that's what we need to do to amplify. Yep.
So the primer is the search function and to see if there's any matches. If there's matches, then it is COVID positive, right?
You can think of it as a search function, but it doesn't really do the matching. It tells how to search. It tells how to search, right?
Are there different primers?
Yeah, there are different primers. Yeah. So a lot of the sensitivity is based on how good the primer is. Right? And we'll go into this when we talk about LAMP, because what makes LAMP unique is the primer design and the ability to search, right, for the target SARS-CoV-19 genes.
Do you need
Yeah.
different primers for different strands?
Yes. So it's like, so if you look back at the picture, it's like a pool of primers and like DNTPs. Like we don't need to go into detail here. It's just a pool of a lot of. Please do. There.
So how many primers can you test at a time?
How many primers can you test at a time?
Yeah. For one sample, like right in your spot or like there's saliva. How many different search functions are we applying to that sample?
It depends. You can apply, in theory, you can apply. It's all about.
So one test you apply only one side.
No, you can have different primers to test for different genes, but it's all about finding the right mix in this so that you can optimize the sensitivity. Yeah, because you also don't want to throw too much in to like jumble with the sensitivity. Yeah, so it's like all about finding the balance. Yeah. In a nutshell.
What's the primer we use for RT-PCR or
So the primer we use is used to detect the N gene of the SARS-CoV-2 and the ORF1ab gene. For the RT-PCR, we look at the N gene. Yeah.
So I get different primers live to see different parts of the SARS
Yes.
virus, right? So if
Yes.
I use a certain primer like the one we are using, we're going to detect the SARS, basically we see the N gene of SARS. But if we use a different primer, it might find another thing. It could also be used as an alternative.
Yes.
So who's the one who approved these primers via different labs and like diagnostic basis? So like standardization of the search function or
Is this open source?
Yeah. So the CDC created a novel in 2019. They created a novel tested coronavirus testing kit. So in that testing kit, they have everything you need to detect it, right? And that's why it's a gold standard, because the CDC kind of like validated and did everything. Yeah. And everything that comes afterwards is like different companies have used like the same formula or same idea to like make it better or try to make it faster. Yeah.
but if they alternate or improve or change the search function or the primers too much, then wouldn't that kind of put the detection level at risk?
Hypothetically, yes. Yeah. So a lot of this is done through like constant validation and wet lab, and it's something that we at Pre-Nice won't do. Yeah. All we do is like we purchase these primers, what we think is best, and we conduct testing. Yeah.
And if anything is changed in the market, we'll just make it update.
Yes. Yeah. And so we like with LAMP, we talk, we work with Oxford University to, especially the new mutated strains, right? Like the UK strain, the South Africa strain. We work to find, so we see if our current primers that are being used affected by the new mutation, because if the new mutation changes too much, right, then the certain set of genes, the sensitivity isn't as high as what we have determined before prior to the mutation. Yeah.
So in
It's the same strain,
No, I mean,
same
so,
virus.
There is a different strain we were trying to understand if the current primers would be effective in detecting those
Yeah.
right?
Yeah.
And then if that's the case, then
The question is that how much later do you get this?
yeah, so why would that get affected? So either it should be protected or not protected. How is it a technique?
Degree. Yeah. So like what Chris said earlier about how primers are a search function. So if the mutated strain mutates, like there's a switch in where the search, yeah, where the search function is supposed to look at, and it's different, then that's going to affect the sensitivity. That you see, it's going to affect the ability to capture that target region of the virus.
So the engine might would still be there. It's just a mutated way. But the way the primer would usually find may be affected because of that. So that's why new strain will get affected by a previous primer.
No, the way that it finds never changes. It's just that when it finds it where it's supposed to be, if it's not there, then it's not there. You get it?
So you can change the search function for the example, Harry blah blah and the blah blah fire. Since you know that the COVID, the end is like Harry Potter and Potter, you can change it Harry Potter blank, the blank of fire. So you can change it much easier or like a shorter search function to detect it faster, right?
Yeah, to make it more accurate. Yeah, if it changes. Yeah.
Does primer test for specificity or level of sensitivity? Like what does it affect? Or it's unrelated?
The primer.
Does it like affect the level of sensitivity slash specificity of the test, or it's unrelated?
No, it's related. It's related. Yeah. The sensitivity part to let me just clarify on the specificity and sensitivity, right? With specificity, if you have different viruses like the common cold, right, and SARS-CoV-2, specificity is like how can I define and make sure that what I'm testing is only the virus, SARS-CoV-2. Okay, so specificity, the definition is, can I every time I test, if I test you 100 times, will I always get SARS-CoV-2 100 times? Okay, but with sensitivity, it's more like how many times of those positive people can I pick up out of 100 times? And it could vary from 90 out of 100, 95 out of 100, 98 or even 70 based on the primer design. Yeah, so that's how important it is.
I thought sensitivity was based on viral load. Is sensitivity based on viral load?
Yes, that also affects it as well.
What you said right now is dependent on the more people you test. Actually, the viral load is not high enough, then the sensitivity. I mean, I guess different tests have different sensitivity levels, and the viral load is not high, then we'll never detect it.
Yeah, so there's variations and there's a lot of variables that would affect the sensitivity. Yeah.
So that's the viral load is one of them.
Yeah, viral load is it's like 80% of it. Right, 90% of it, the predominant cause, and the lesser cause 10% would be the primer design. Because in theory, if you talk about mutations and changes, they're very small and they shouldn't affect the overall aspect of the virus, right? If you look at, I'm not sure if you remember biology back in the day, but the base pairs are ATGC. You know, we're talking about substituting one letter for another letter, and that in and of itself would not affect the overall virus or the structure, right? Or how it will be detected. It's more of the viral load that would affect the sensitivity, right? But since we were on the subject of primers, that also
There's a
affected.
part, but not very minor.
Yeah. So that's why the scientists who make these primers need to make sure it's validated and it's the right set so that the sensitivity is as optimized as it gets, right? And then when it comes to detecting the viral loads, that is the other 90%. Yeah. Okay, cool. So some of you guys on the operations team might have this question: what is CT35? What is CT15? What is CT20? As a lot of us are here in the office, the lab on the other side is another world. And if you look at this graph, can you guess what CT35 or CT19 might represent?
Zoom, the virus.
Yeah. Close.
Degree of infection.
Yeah. Yep. Closer, closer.
How's that detectable? Is the virus?
Yeah, detectable device, the viral, like the viral load. Yeah. So I over here on the x-axis, I've added the high viral load and low viral load for your reference. So basically, with the CT, it's just a cycle number, and as the virus, if you remember the hairy and the goblet fire analogy, as it constantly amplifies over time, if there's a higher viral load, then the CT value would be much lower because it represents when, at what time does the virus amplify for the PCR to detect the virus. Yeah. And then at low viral load, you expect the virus to rise up at a later time because it has a lower viral load, which corresponds to a higher CT number. So the CT number essentially represents when amplification happens and how much viral load is there in the person getting tested, right? And if we try to put some context into why viral load matters, higher viral load, a person with higher viral load is much more infectious than someone who doesn't have high viral load. Right? Someone with low viral load is more like on the asymptomatic or at the stage where they were just infected with COVID-19 and they're not displaying any symptoms at all. Yeah, so these are the population, especially in Hong Kong, that we want to capture because they often fly under the radar for most tests out there.
Sorry, what is cycle number?
Cycle number refers because I didn't explain this much in the PCR because I want to explain it as much as simple as possible. But PCR is a thermal cycling method, so it uses various temperatures to amplify the virus. So cycle number refers to the amount of cycles, the amount of times it goes through different temperature stages to amplify the virus. Yep. Questions? No. Yeah. This threshold entails on the PCR instrument, the what do you say? The threshold represents when will the instrument, the PCR machine, call a certain amplification curve positive or negative, right? It's the threshold is used to detect to differentiate positive samples from negative samples. Because oftentimes when you run like a certain batch of samples, like 90, if you were to run 96 samples, the rate of positive, the chance of you finding a positive sample is probably 2 in 96, 1 in 96, depending on the severity of the outbreak. So that's why a certain threshold is required so that you can differentiate the negative cases from the positive cases. Yeah.
It's
You mean if the graph, if it goes beyond, then it's positive, right? But if it like crosses over here, then you know that the person is a low viral load.
it's a city numbers changing by person or it's a standard per lab?
It changes by person based on how sick they are. Right?
Okay. Yeah.
Right?
Because I was reading that for some labs they're setting up like a one city number for themselves, like, for the people.
Well, like you mean in Taiwan?
Yeah.
Yeah, in Taiwan, what they did was they basically announced that anyone past CT35 is not infectious with COVID-19.
Yes.
Yeah. So anyone before CT35 is considered positive with COVID-19. All right. I hope that answers your question. Yeah.
Mhm.
So you can set the standard, but the standard are normally set back here because everyone here is they have high viral loads. You cannot exclude
Yeah.
them from diagnosis.
It's just on the paper.
Yeah.
Are samples below the threshold negative and above the threshold positive?
Yes. Okay. Any questions? I'm going to move on to LAMP.
Does different country have different standards?
Yes. Hong Kong has a very high standard. Like Hong Kong really wants to detect 35 and above. So they're quite relentless in pursuing this objective. Well, I know that Taiwan was very public about 35 as a cutoff. I'm not too sure about what other countries cutoffs are. Apart from that. Okay. So moving on to LAMP, why oxygen lamp is revolutionizing COVID-19 testing. Okay. So at a glance, with oxygen lamp, is a test developed by Oxford University that utilizes the same principle, reverse transcription. Right? You remember what reverse transcription is? Yes.
RNA to DNA.
Good, nice. That is keys. So the process of RNA to DNA is LAMP, right? And the best thing about it is that it takes 30 minutes to complete, and the results can be analyzed by color change, right? So if you look at the differences between RT-PCR and LAMP, in fact, they're very much pretty similar in all aspects on a molecular level. But if we look at the temperature, testing time, and instrument requirements, LAMP takes 30 minutes, while a normal RT-PCR test takes 80 minutes to finish, right? But if you factor in the operational time as well, for processing RT-PCR versus RT-LAMP, for RT-LAMP, it would take 40 to 1 hour to provide results to the person getting tested, while RT-PCR, it would take 80 minutes plus, normally on an average of 2 to 5 days, right? If you're testing a large capacity. And plus, with the instrument settings, the RT-PCR is complicated and expensive, right? In the lab, I'm not sure if you've seen, they're big machines or small expensive machines that are required for the test. But LAMP requires one temperature at 65 degrees, so it only requires a heat block to perform the test.
Do we touch based on rapid PCR?
Rapid PCR?
Yeah.
No.
How would rapid PCR be different than that same test? All of it. The rapid PCR test. So I mean, you have RT-PCR and RT-LAMP.
Yeah.
And our rapid PCR is usually longer than RT-LAMP and shorter than RT-PCR.
Our rapid PCR?
Yeah.
The Coyote? Oh, you mean the Coyote test? Oh yeah, that is 30 minutes as well. Same with LAMP.
How would that be different
Than
than
RT-PCR?
Is looking for the protein of the virus.
on a general level?
On a general level. Let's see. What?
Like doing one temperature or like doing multiple temperatures faster? Or is it a workflow hack?
With the RT-PCR Coyote Flash 20 that takes 30 minutes to finish, the difference between that and the RT-PCR is that in the primer mix, there's already a set of hot start and a certain set of hot spice elements. They planned it so that you don't need to so that you can skip the first 2 stages of RT-PCR. The RT-PCR is a long thermocycler process where you use different temperatures. But in Coyote, you don't need that many levels of variation for temperatures to amplify the virus, because the primer set is already defined.
That depends on the primer or primer set different from primer.
Sorry, say that again. The primer set is different. The Coyote one.
Just when you say primer set, are you meaning primer as well? Or
Yeah, the primer as well. Yeah. It's in the mix that makes it different for Coyote, because they have like buffers, right? In short, they have special ingredients to skip certain stages of the normal RT-PCR. Yeah.
there's some magic in the primer that allows to
Yes.
amplify the virus.
Yeah. Yeah. Certain stages are still similar with the RT-PCR, but it's in the ingredients that makes it work faster. Yeah. Okay. Cool.
So no machine difference.
No machine difference.
Coyote just makes primers.
No, they have their own machine. Yeah.
But that's independent of why rapid PCR.
Yes. Yeah.
I got it.
We'll go into detail on the rapid RT-PCR in the future. Yeah. We'll talk more about LAMP. So to understand LAMP, the best way to go about it is to think about the hot pot analogy, right? And I'm pretty sure we all know what is a primer now. Yeah. Are you hungry, Christian? Okay. So how does LAMP work? As I said before, LAMP is isothermal amplification. So it requires one temperature at 65 degrees. As we know, with primers, they're basically in the instruction guide, right? So imagine a soup base. The soup base has all the flavor and it has all the necessary, I guess, touches to make whatever food you put in taste like soy sauce or taste like kimchi, right? So you have a soup base and raw food. You add the soup base and raw food into the boiling soup at 65 degrees and you cook it for 30 minutes, right? And out comes cooked food, right? And when you see cooked food, you see a color change from, pink to brown. And then if you don't see a color change, and that, that itself will tell you that, oh, that's positive. And you see a color change, then, oh, that's negative. If we're talking about food. Now apply this logic to lamp. Okay, so lamp, you have a bunch of primers. You toss it in at 65 degrees with the sample, and out comes a color change with yellow and pink. Yeah. So with pink, that is a negative sample, and with yellow, that is a positive sample. So this color change happens with lamp, and that's why it's very easy to understand and very applicable across many settings worldwide, because it doesn't require much skill to really interpret these results, nor does it require a complex machine like RT-PCR to really understand what's going on. Yep. Do you have any questions on LAMP? No. Okay, moving on to the antigen and antibody COVID-19 testing. Okay. So some of you might have certain confusions as to what's the difference between an antigen, what is an antigen, the difference between an antigen and antibody, and how does it differ from the oxide LAMP test, right? So let's break it down and understand the background of what an antigen is and what an antibody is. So an antigen, in short, is a viral protein, okay? So these things over here, this is SARS-CoV-2, and that red spike thing is antigen. So when your immune system sees an antigen, your immune response, your T cells and B cells will recognize this and fight off the virus. Now the antibodies are these Y-shaped proteins. So when they sense these antigens, they react. Yeah. So my best analogy for this is to think of Pac-Man, right? So Pac-Man is the antibody, and antigens are these little things that it would just eat, right? That's how it works. The antibody would just bind to these antigens, and what it does is that it's these antigens are specific as well. So different shapes exist out there. So that's why challenges to making a vaccine matters, because of the different shapes and sizes of the antigens, and their binding is like putting a key into a lock. It's very specific. Yeah. So that is an antigen and an antibody. So before understanding the test differences, can you guys spot the differences between these two pictures? Nice marketing perspective. Yeah. Huh? Yeah, this is a pregnancy test. Yeah, this is a pregnancy test, and this is the Abbott's COVID-19 test. Yep. And the thing is, with the pregnancy test and the COVID-19 antigen test and antibody, they're very similar in terms of how they work. Okay. So with the pregnancy test, right? I'm sure. Does anyone know how to explain a pregnancy test or how it works? No. Okay. I didn't hear that. Yeah. So in short, a pregnancy test, they detect a hormone during the period 6 days after fertilization, if it happens. So they look for levels of these hormones, right? And then this is the test. This is what it looks on graphic. You get the sample pad, the urine, I guess, and then the antibodies, and then you would see these lines based on the antibody binding if you're pregnant or not pregnant. Okay, so we apply this concept to antigen testing. Okay, so with antigen testing, what it does is that it has like a sandwich binding mechanism for how it detects these antigens. So before use, what you do is you collect the nasal and throat swabs, and afterwards you apply these nasal and throat swabs onto the test kit that they give you, and then as it processes, this antibody binding occurs, so it just detects whether the virus is present or not present. Right. So that's why the sensitivity is around 50 to 90%, is because these antigens cannot be amplified. They are the surface proteins of the virus and only can tell you if the virus is there or not there. So with antigen tests, the key is that they can only be used within the first 7 days of symptom onset, when the body is incubating the virus and the person has high viral loads. Because the only reason for that is that the sensitivity is high when it's detecting these proteins. Otherwise, if you don't have these proteins, then the antigen test won't really detect whether or not someone is asymptomatic or has low viral load. Yeah. Now with an antibody test, it's very similar as well. What it does is that it uses blood as a sample type, and the time it takes several days to produce the results. And the difference between an antibody test and an antigen test is that with an antibody test, it's used to determine if you had a prior infection to COVID-19. Yeah. So what it only tells you is that if you've been sick with COVID-19, do you have these antibodies to protect yourself, and B, do you have this past infection? Yeah. So this is more informative, and it's not really used for screening purposes. Yeah. Questions? Yeah. These. Yeah. So these are just these are just names for antibodies. Because we have different antibody shapes. So this just detects a certain type of antibody that has been detected if you had an infection, right? But the principle for how they detect is very similar to pregnancy tests.
Can you have a COVID? I mean the coronavirus, but not COVID.
Can you have the coronavirus but not COVID? There's the same thing.
Coronavirus and COVID is the same thing.
Yeah, the name is different. But the coronavirus is a family of viruses that fit within the category because of the shape and the properties of it. But the COVID-19 is different from coronavirus.
Yeah.
Yeah.
So you can have a coronavirus but not COVID.
Yes. Yeah. Yep. Processing time. This is wrong up here, but it takes several days. Yeah. Why it takes several days? I'm not too sure. Does anyone know? The strip test? No, because based on what I've like identified or researched online, it says several days. But if it's a strip test, then yeah, an hour. Do you have an answer for that? Yeah.
Yeah, 15 to 20 minutes. Yeah.
Okay, so that's right. Yeah. Okay. Yeah.
When I was doing a stock trip in UK, I've seen those control tubes for pink tab and the yellow tab in the warehouse. So how does that work? Fitting into the argument.
The pink tab. Can you elaborate that?
With like pink cover and the yellow cover, and then that actually put up something called positive control and negative control. I guess
Oh,
that was
okay, yeah, yeah.
how does that fit into the tab?
Okay.
In terms of the procedures.
Okay, yeah. Let's see. I don't have the slide anymore. Okay. In terms of the procedure, The yellow cap is the positive control, and the pink has the negative control. So what it does is basically you toss these controls into 65 degrees, and they will amplify along with the other samples as well. So it goes through the same process, but you do the negative control first to prevent contamination, and then you do the positive control, because the positive control contains the armored SARS-CoV-2 RNA. Yeah, and that itself would get amplified in this process, and the negative control does not have that RNA. It's just that it contains the human gene, the human strand, so that gets detected in the process. But they all get subjected through this flow.
So I'll choose that one path to apply two tubes, right? It must have a negative and then the positive one.
Yes. Yes, every test that is done requires a control so that you can compare the set of data with the control and make it standardized. Yeah. But in terms of how it works, it all goes through the same flow. Yeah.
Why does land does not is isothermal and then PCR is changing temperature? What's the difference? Why does you can use isothermal, the others not? What's so special?
To explain that, isothermal uses the property of this is going to get more technical. I like.
Go for it. Yeah.
Okay, so with LAMP, what it's unique about LAMP is that it uses loops, right? If you can see these loops, the reason why 65 degrees can be achieved is that you have these forward primers and backward primers. So these forward primers will go one way, so it goes this way, and the backward primers go that way. So when they both go in opposite directions and they form loops, then at one temperature it would constantly just form these loop structures and elongate the reaction, making it broad and sensitive. Yeah, but with RT-PCR, what it does is that at different stages, it doesn't have this mechanism of loops, right? That's why you don't have this name loop-mediated isothermal amplification. There's no loop that's being formed on a molecular level. What happens is that it's just reverse transcription. The reverse transcription happens here, but then in RT-PCR, it's only reverse transcription of RNA to DNA, and you have polymerase as well. It's amplifying it at different cycles. You have denaturing, elongation. Yeah, but the key thing with LAMP is that it forms these loop structures, which is why it can be achieved at 65 degrees, right? Yeah.
So why is there a color change? What's the magic?
Oh, the magic.
You can just tell based on the color change there's a lot.
Yeah, so what is being used in this color change is that a dye called phenol red is used. So as it amplifies, this phenol red gets subjected to color change if the virus is present based on dye emitting mechanisms. Can I say that? dye emitting mechanisms. Is that general explanation? So, dye emitting mechanisms.
I mean, there is a slight acidity change after
Yes.
the reaction. So if the color change depends on whether it's acid or alcohol. So when this change, positive is yellow.
Yes.
Yes, yellow is more alpha or neutral, but then red is more acid. So during the reaction, when there's water there, that leads to a slight change to the acidity towards a more alkaline. That's why there's
Have the expert.
The lamp technology is patented, or it's anybody can use this technology.
It's patented.
Patented.
Yeah.
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 Okay.
Prenegs are legal owners of LAMP.
So why does different companies use the technology?
Oh, this technology exists since back in like 2005. for like different purposes. It's only just been adopted by different laboratories and countries around the world, and each of them have their own way of going about lamp. But Oxid, what they do is that in their primer design, they added a very specific detail to make it more specific. Yeah, I'm just gonna say that because it's
I
very
understand.
detailed for how they do it.
So they looking for specific stuff to later technically colorize the elements,
Yes, because
positive or negative.
normally if you just see how it works
Yeah.
with just loop structures, it's just in general, sometimes it's not as specific. But what Oxford did, like Oxford, they kind of make it stop at one point. Yeah, so they added like another step in it. So it's all these very detailed molecular additions or subtractions to the process that makes or break what it becomes
And
in the
also
end.
you can speed up the process.
We are trying to do that.
Yeah.
We're trying to do that.
The 5
Or already
minutes.
did, to 25 minutes if possible.
Yeah.
Yeah.
The lab in Poland already did it in 5 minutes.
In 5 minutes,
5 minutes.
this whole thing.
Yeah.
How sensitive is it?
It's 97, and the first one is what? First one is what is the sensitivity of
Specificity?
sensitivity to 97 is
Mm. Oh, yeah, I like to look at that.
yeah, I can send it.
Sweet.
It just close like so many millions of around stuff.
Okay.
Let's say I want to use lab as like a daily necessity, like an application to create a social bubble that I know, like, let's say if I want big gatherings, like people do the test first, so that they can come in for like, let's say family dinners, like friends and everything. Let's say now we know the incubation of the virus is like 19 days. That's only like 3 times like 21 day of quarantine. In that sense, how often would you like what's the spacing in between? Like every 5 days you do a testing, so like you screen it for 2 times, then you can attend this gathering to ensure that you're safe, or should it be like every 3 days for a testing? Is there like a recommended guideline or spacing in between to make sure people like go into this gathering, this social bubble, like everyone is guaranteed like COVID free?
Good question. I think guarantee is very hard to do in testing, especially if you're trying to create a bubble. Because you never know who and when that person is going to be with, unless there's a fixed bubble, like how they do in the English Premier League. So that's why with screening, and if you're trying to get tested with all your friends, right? If you're trying to create a bubble, then everyone has to get tested at that moment in time. Then the result afterward is valid for that certain amount of time for like 7 days, right? Like first you have to quarantine. First they have to quarantine like 14 or 21 days, right, before they get tested, because you know that they haven't had contact with anyone outside, right? So the test result is valid. But if there's like no quarantine or isolation process before it, and you get tested with this whole lamp thing, then at that moment in time after the test, if anyone is negative, you know they are negative just for that day, because you don't know if they contracted the virus and they are incubating the virus, right? Like the first day, you don't know their timeline. That's my point.
So
Right.
when you're designing the bubble, it's not testing the important part, that logistic of the movement of the people. So like for example, yeah, so one of the additional for the different organizations we need to loop the band, so that's additionally the part of the sleeping pattern that they have some connection. Testing, yeah.
I think if you really would like to do it into work, then you should make it daily habit, just like you drink water. So you have to do it on a daily basis. Because the viral change can happen within 10 hours from not detected to very high viral. So that can happen. So if you would really push that would be daily. So, and I'm really not invested in this or
Yeah.
just infection?
Um,
Yeah.
yeah, that so that is, according to the analysis of what that is by RT-PCR, that is indeterminate, right? And it's indeterminate for a reason, because those people who are with CT38, yeah, they exhibit very low viral loads, but what RT-PCR in terms of their timeline for screening, uh, or testing the people that can fall within the criteria of detection is from the first day of contracting the virus to their last day of recovering from the virus, right? So, it depends on what your definition of infected is, right? Because it's very subjective for that definition. Yeah, it depends on what the definition of infected is.
I mean, the definition is very clear, whether the test is detected or not.
Yeah.
So it's very clear. So about the threshold is detected.
Yes.
Below the threshold is not detected. But then whether you can judge on this person is currently being infected or just recovered is very difficult. Because it can be an early stage of infection or someone who's been infected and then discharged and then recovering, feeling better. And then the stage can last for quite a long time. Some people might appear on and then not detected 1 month later, but then some people can last for 3 months. It's still can detect it, but then the virus is not infectious. But this cannot be decided by our test alone. So you have to do some viral cultures to see whether that virus is not infectious. So but just based on whether it's detected or not detected, you can only say the test can detect the virus. But then whether that person is infectious or not, or recovered, or just starting to have symptoms or not.
Yeah.
Oh.
And that's one of the main reasons why we do we just detect the virus, and we also send confirmation to CHP, because we cannot like what Belinda said, we cannot we cannot diagnose the person, we can only detect.
I also feel like a very extreme case in the house where like the person tested like 10 times until they were testing positive. I'm just wondering like why would this happen?
Which country?
Oh,
China.
China.
Yeah, so
So
is
for
it because the viral
discussion.
load, or is it because of the testing method or the
It's mostly down to how the virus is incubating or what it's doing inside that person, right? So that person must have been asymptomatic in the first place, and B, correct me if I'm wrong, they they're at the end of their stages for infectiousness, or they have low fragments of the viral load picked up within them, right? But they're not significant at all in terms of how infectious they are. Yeah, and if that test was like an RT-PCR, then yeah, like very low fragments, they could be dead, right? Not active, right? And you detect these fragments, so it's very inconsistent. Maybe if you think about getting tested 10 times, and that's 1 out of 10. So just shows like, at these low viral loads or even lower, you can have fragments, and these are residues of the virus, of when it was active. Yeah.
Viral level inside that person's body is very low. But somehow, the dimension that very high know whether that person is infectious or not, be able to now
Yeah.
determine if that person
actually is on the base of the receiver?
Yes. I'm not sure. I'm not so sure how to answer that question. To be honest.
I don't think there's like a version of decision of this. So actually the data accumulates are still playing this for making such judgment. Because whether it's questions or not, depending on what number of factors. So at the early stage or late stage or the upper stage at that person, and then the people in contact with that person, the immunity of that. So it depends on lots of factors. You cannot judge. But currently, the clinical community is using clinical symptoms as a judgment to see whether that person can be released from the hospital or not. And then based on that, and also on the development of the antibody, because if antibody develops at this stage, can see this person has already going through that period, and then suppose it's not infectious. And then currently they are using about 10 days or something like that. But based on what our contact with the positive case or that they are recovery, and we do see when they do the PCR test, that can occur several months later. So it's not 100% sure because it's actually depending on everyone's individual. So someone might be infected or someone might not be. That depends because every individual.
Okay.
This assay still be accurate because of the mutation in UK version, Africa version, or
Brazil. For that, which assay? Oxidland.
In general.
Oh no, the assay is still valid because it detects the virus and the strain. But you just have to prove it that it is valid by doing tests of the new strain on the assay to see if there are any differences. According to our LAMP technology, like we've done tests to see if the South Africa and UK strain affects our assay, and it doesn't. We're still able to detect them up to CT32. Yeah, and that's our sensitivity standard. Yeah. The salmon?
Like
Seafood chain, yeah.
like for a long way.
Yeah.
Have been detected how, I guess, contain some chocolate.
The fish?
You know, like the
Frozen packet.
Yeah. So I'm wondering, given mention of the virus not really stay on like non-human or non
Yes.
biology kind of surface
Yeah.
for that long time. But why it kept the confidence and also why people are concerned about that?
That's a good question. I think the primary reason is because in frozen packages, they're very cold, right? Like they're like -80, and it's a temperature that plays a role in the durability of the virus in the environment, right? The reason why some people are, or why the news outlets are always saying that, oh, during the winter times, the winter periods, that's when the virus is going to be much more effective and grow by numbers, is because of the temperature, right? Like if you think about places where it's really cold, those we're talking about freezing temperatures in the air, and that already is beneficial for the virus because it's not going to die out there, and it will persevere longer than something that's hot, because that unstabilizes the virus. To give you context, anything that we store in the laboratory, like if it's samples, like we freeze them in -20 or -80, right? And food packaging would be -20, like they would be frozen, right? They wouldn't be like refrigerated. So that frozen element preserves the viruses. Yeah, it's temperature, like a temperature roll.
Okay, let's do vaccination.
So this is the end of Q&A.
No vaccination questions. Next one.
Next time we'll talk about vaccination. But thank you all for attending the Q&A.
Yeah, good job, man.
All right, bye everyone on Zoom.
Yeah. Great.